Welcome to almost done with our chemistry session. Okay, so today I want us to have a look at the reactivity series. Hi guys, welcome to Memo's tutorials. We are almost done with the chemistry session, and today we are looking at the reactivity series. Please don't forget to share our videos, don't forget to like, and also to subscribe to our YouTube channel. So now, looking at the reactivity series, we are saying carbon and hydrogens are not metals, but we have placed them also on the reactivity series due to their characteristic reactions with metals, right? So to remember the above elements in the reactive series, you need to master, or for you to cram, you must know the phrase, "Please stop calling me a careless Zulu." I'm highly complex. Please, sorry about that. So we are saying, please stop calling me a careless Zulu. I'm highly complex, right? So the reactivity, what we need to know is that it decreases from potassium to copper, right? So now, please, it stands for potassium. Potassium starts with a P, though we know the chemical formula of the symbol is K, right? So please is for potassium, stop, that's sodium, calling, that's calcium, me, that's magnesium, A, that's aluminium, careless, that's carbon, Zulu, that's zinc, iron, that's iron, highly, that's hydrogen, complex, that's copper, which is the least reactive element. So make sure you know this phrase, please stop calling me a careless Zulu, I'm highly complex, right? So reactivity, we said it decreases as you go down. So meaning to say potassium, that's the most reactive, and copper, that's the least reactive. So we need to be able also to place in order of reactivity. We have potassium, sodium, calcium, magnesium, aluminium. We need to place them according to their order of reactivity. So if you master the phrase, then you are good to go, right? Then we have got water or steam. Remember that carbon and hydrogen are not metals, so they do not react with water or steam. So reactivity of the above elements with water, it decreases from potassium to iron. So from the list, only copper does not react with both water and dilute acids. So the metals above, the metals potassium to iron, they are the ones that react with water to form the metal oxide and hydrogen gas. So the metals, actually, these ones, they displace the hydrogens in water molecule, and in turn form a bond with the oxygen, which had previously been bonded to the displaced hydrogen. So hydrogen in this case is then displaced as hydrogen gas. So metals also displace hydrogen in dilute hydrochloric acid, for example, and in turn bond with the chlorine of the hydrochloric acid to form chlorides, which are certain salts, right? So dilute hydrochloric acid, we are saying that metals, for example, potassium can also react with dilute acids. You know, when you react a metal and an acid, we get a salt and a gas, right? A metal and we said get a salt and the hydrogen gas. So we are saying copper is less reactive than hydrogen. So this means that copper cannot displace hydrogen from its compound. That is why if we need to make a salt of copper, we react copper oxide with dilute acids and not copper with dilute acids. So copper oxide reacts better with dilute acid compared to pure copper altogether. So reactions of metals with either water or dilute acids, we call them the displacement reactions, because hydrogen is being displaced from its compound. It's either we're displacing hydrogen from its water or hydrogen from the acids, right? So we are saying the reactivity series is like the world heavyweight boxing champions, whereby the elements are fighting to wear the belt. Either oxygen if reacting with water, or chlorine if reacting with dilute acids. So these elements, they need to displace the sitting champion. The sitting champion can be hydrogen in this case. Only those elements ranked above hydrogen will be able to displace it. So you must take note. We said carbon is not a metal, so it's not going to displace any hydrogen. And also that hydrogen cannot displace itself, because if hydrogen displaces hydrogen, then the overall change is zero. There's no change at all. So now the next thing we are saying, reduction of their oxides with carbon. So metals are usually found in nature as ores, so which mainly consists of metal oxides. The extraction of a metal from its ores depends on its reactivity. So a more reactive metal usually requires tougher methods of extraction compared to a less reactive metal. So only zinc, iron, and copper can be extracted from their oxides through heating with carbon. A carbon is a very, very good reducing agent. Are we together? So all these metals are below carbon in the reactivity series. So now we need to be able to describe the reactivity series in terms of the tendency of a metal to form its positive ion, which is illustrated by its reaction. So if any, with the aqueous ions or other listed metals. So what do we say? Reactive metals easily form positive ions by easily losing electrons. They donate electrons. So when a more reactive metal is placed in a solution containing aqueous ions of a less reactive metal, for example, when calcium is placed in a solution containing aqueous ions of copper metal, so the calcium metal will form calcium aqueous positive ions by losing its outer two electrons. So these electrons are picked up by the aqueous ions of the less reactive metal and convert those ions to metal atoms again. So what do we mean? Calcium metal plus copper nitrate, we get calcium nitrate and copper metal. Copper has been displaced from its what? We've taken the belt away from copper and gave it to calcium nitrate, right? However, no reaction occurs when a less reactive metal is placed in the salt solution of a more reactive metal, because it can't displace a stronger champion from its compound. So no change is seen when copper metal is placed in magnesium nitrate, because magnesium is more reactive than copper. So the next thing that we're going to look at is the extraction of metals from their ores, right? So we need to describe the use of carbon in the extraction of copper oxide. So we in the extraction of copper from copper oxide. So we're going to look at that on our next video.